In this crash course, we're going to take a look at TypeScript. I'll teach you what it is and how you can use it in your next project. TypeScript is a superset of JavaScript, and that means that it can do everything that JavaScript can, but adds more features. The main feature that it adds, as its name implies, is static typing. In regular JavaScript, you can create a variable of names and assign a string to it, and then later on, you can reassign a number value to that same variable. JavaScript uses dynamic typing, which basically means that you can assign anything to anything. It's like the Wild West. So we need some rules to keep ourselves from making silly mistakes. Adding static typing helps us to catch bugs before we've even run our code. And the amazing type checking that's built into VS Code helps us with this. By using TypeScript, we force ourselves to write cleaner code from the start. Now, TypeScript cannot be read by the browser, and so we will need to compile it to regular JavaScript before testing or deploying, but that's really easy. The first thing that we're going to do is set up our local environment to do this. Before we go any further, you do need to know JavaScript first, so arrow functions, objects and array methods, the DOM, classes, etc. If you aren't up to speed with those, be sure to check out my JavaScript Beginners course and JavaScript January series. The links are in all of the places. Let's take a quick look at types. Types are not exclusive to JavaScript, and they are common in other languages like C# and Java. The TypeScript types that we're going to cover are strings, number, Boolean, array, object, any, void, null and undefined, tuple, enum, and generics. So let's get our environment set up for TypeScript. First, you'll need to install Node.js if you haven't already. We'll need this for its Node Package Manager. You can check if you have it by typing node v, and that will give us the version of Node that's installed. I currently have version 12.18.2. So next, let's install TypeScript globally. So we're going to say npm I for install -g for global, and then TypeScript. Next, we're going to initialize TypeScript by typing in tsc --init. And that creates a tsconfig JSON file. There are a ton of options here, such as the JavaScript version. By default, it's set to ES5. So you can also specify your root directory and output structure if you have a source folder and build folder, for instance. But that's for a more advanced setup, so we're not going to cover those features in this video. Let's create some files. We'll close this. We're going to create an index.html and app.ts. Now notice here that the extension is .ts, not JS. Since TypeScript extends JavaScript, we can write plain JavaScript in there and it will work just fine. So we could say console log, and we'll say hi, and this works just fine. So let's go back to our HTML and just create a basic boilerplate here. We'll say TypeScript crash course. And then let's add our script. So that's going to be script with a source, and that's going to be app.js. And we're going to defer that. Notice here that this is .js, not TS. Browsers cannot read TypeScript files, so we need to compile it down to JavaScript first. So let's open up our terminal, and we can run the command tsc, which is TypeScript compiler. This was installed when we installed TypeScript globally. This command accepts two optional values. We can tell it specifically which file that we want it to compile. So we could say app.ts, and then optionally what we want the compiled file to be named. So we could say something else.js if we wanted. But for this instance, we only have one TypeScript file, so we're just going to run tsc. And now we can see that it created the app.js file. And there's not going to be any differences here, really. We just have console log hi, console log hi. Let's go ahead and run this. We'll open it with live server. And then we'll open the console. And we can see that it logs hi. So we just used plain JavaScript. So let's go back into here, and I'm just going to paste some TypeScript. And don't worry about what this looks like. You don't need to understand this right now. You will understand it by the end of this video, though. So let's save this, close the sidebar. And now we'll need to run tsc again for it to recompile. And then we go back to our app.js, and we can see that it has recompiled this into regular JavaScript. And notice that it's using var instead of let, and that is because we were compiling it down to ES5 standards. So let's look at some basic types. Really quick, like and subscribe, it helps me out. The first type that we'll look at is a string. So we'll say a string equals hi. And now if we hover over this, you can see that VS Code is telling us that this is a type of string. If we try to reassign a string to a number, you'll see that VS Code is yelling at us, or TypeScript is. It's telling us that a number is not assignable to type string. So a string always has to be a string. We could change this to another string, and that will be just fine. Now, if we need to initialize a variable and then assign a value later, we have to explicitly declare the type first. So to declare a type, we use a colon and then the type, which is string. So now a string must be a string. If we try to assign a number to it, it's not going to let us, but we can assign a string. Now, alternatively, we could do this. We could say a string is going to be a type of string and it's going to equal a string, but this is kind of redundant and unnecessary, so you really don't need to add this type here because it's implied when you assign it to a string. All right, next we'll look at numbers. So we'll say let a num equal 5. So again, TypeScript has implicitly declared that this is a number. And if we try to assign a number to a string, it's not going to let us, but we can assign it to another number. And then again, if we need to declare this before adding a value to it, we would say a number is a number. And then we could say a num equals a number. All right, the next type that we'll look at is a Boolean. So we'll say let a bool equal true. And we hover over this, we'll see that it is being assigned to a Boolean type. And so again, if we try to assign anything else to this other than a Boolean, it's going to yell at us. So we add a number, it's going to say that the number is not assignable to type Boolean. So we could change this to false, and that will work just fine. And again, if we need to declare this first before assigning something to it, we could just do like this, add a type to it. Now, if we were to just say let any var like this, and we hover over that, you'll see that it is of the type any. So any undefined variable will default to this type of any. If we say any var equals a string, then it's going to default to the type of string. But if we wanted this to be the type of any, we could explicitly define that here. And now it's of the type any. And so we could go here and say any var is now equal to 5. And that's going to let us because this is of the type any. It can be any type. And this is really the default behavior of JavaScript. So it really defeats the purpose of using TypeScript. And I would try not to use the type of any if at all possible. Now, there may be instances where you need a variable to be multiple types. So let's say, for instance, let year, and let's say our input is going to give us possibly a string or a number. So we can say that year is a string or a number. It can be either. This is called a union, and we use the pipe character to define the or. So now we could say year equals 2021, and that's just fine. We could also say year equals 2021, and that works as well. But we couldn't say year equals false. That's not allowed. So maybe later on in our function, it has a const of parsed year, and then it's going to equal parse int, and then year, and then we'll know that we'll always have a number here. We can see that parsed int is now of type number. All right, next let's look at arrays and objects. So first we'll say let array string equal, and we'll just have a string in here. So we have an array of strings, and if we hover over this, we can see that it is of the type string with square brackets. So that would be just like saying string like this. And so now if we want to reassign some variables within this, we could say array string, and let's take the first index. If we say that it is equal to 1, that's not going to be allowed because it must be of type string. We could reassign index 1 to another string, and that would be just fine. We could also try to push something into this string, let's push a number. That's not going to be allowed, but we can push a string. All right, same thing with numbers. So we can say let array number equal an array of numbers. And if we hover over that, we can see that it is of the type number with square brackets. So same as saying number square brackets. And again, if we try to reassign things, say number array 0 equals string, that's not going to be allowed. But another number is just fine. And if we try to push a number, that will be just fine, but we can't push a string. And then an array of booleans, so we'll say let array bool equal, we'll say true and false. All right, so if we hover over this, we'll see that it is an array of booleans with square brackets. So the same as boolean square brackets, right? Again, typing this is redundant if you're assigning it, but if you need to declare it first and then assign it later, then you do need to declare the type. So then again, if we say array boolean index 0 equals a number, that's not going to work. String is not going to work, but we can change it to false. We can also do array boolean push, and we can push another boolean, and that will be just fine. So now what if we want a mixed array that has strings, numbers, and booleans? We can do that as well. So we'll say let array mix equal 1, a, and true. So we can do that just fine. We hover over this, we'll see that it is a union, basically, of string, number, and boolean. So if we were to declare this first without assigning variables to it, we would say string, number, boolean. But because this is an array, we have to wrap it in parentheses, and then after the parentheses, square brackets. And I need to spell boolean correctly. There we go. So now this array can have any of these types within it. So because of that, it kind of defeats the purpose of TypeScript. But so we can say array mix, and we'll take the first index, which is originally a number, and we're now going to assign a string to it, and it's going to let us. So I don't really like that. We can also array mix dot push. We can push a string, we can push a number, we can push a boolean. It doesn't matter. Any of these will work anywhere within this array. So maybe you have arrays where that is necessary, and that's just fine, but that's something that we just need to be careful with. So now what if we only want to allow certain types in specific spots of the array? So that's called a tuple. So we're going to say let array tup equal a string and then a number. So by default, this is going to say that it is a union of string or number and that those can go anywhere. But we want to explicitly define the spots within the array and what they should be. So to do that, we will have to say string and number. So instead of defining on the outside of the array here, we're defining inside the array, right? So we have the square brackets, and then inside it, we're going to say this first index 0 has to be a string, and index 1 has to be a number, right? So now we go down here, we could say array tup equals, and we can change this string to another string, and we can change this number to another number, and that's just fine. Now notice how I didn't have the number here. I only had the string. It's telling us that we need a string and a number. We need both. So we have to add a number in there. Now, if I tried to do a number here, that's not going to work. It's going to tell us that we need a string. And if I tried to add a string here, that's not going to work. So it must be the other way around. String and then number. All right, now let's look at objects. So we're going to say let person equal, and this is going to be an object. We'll say the name is Jesse, and age, we'll say 25. Sure, why not? So here we're implicitly defining the types within this object. So we have a string here, and we have a number, and then on the object itself, it is a name with string and an age with number. So this person object must always have a name and an age. And we'll see that right here. So if we say person.name, we could say equals another name. We'll say John. That will work just fine. But if we try to say person.name is a number, that's not going to work. We need a string. The same thing with age. We also can't say person equals a string or anything else because person has to be an object. It needs to be an object with the name property and the age property. And we also can't add on to this. So we can't say person.email equals something because email does not exist in the type person. All right, next let's look at custom types. So if you find yourself using a union over and over, or you have specific type that you want to reuse, you can use something called type aliases. So let's say let year, string, or number like we had earlier. If you're using the string and number union frequently, we can create its own custom type. So we can say type, we'll say string or num equals string or number. And now we can use this custom type here to define our year. Of course, then we could say year equals 2021, or we could say year equals a string 2021. So now you can reuse this type anywhere else in your code to define something as a string or number. All right, next let's look at functions. So we'll say function, we'll say calc sum, and it's going to be passed two values. And then we're just going to return A plus B. All right, this is a very simple JavaScript function. This will work just fine in regular JavaScript. And we could call calc sum, and we'll say 2 and 2, and so that would return 4. And you can see the TypeScript is kind of yelling at us. It's assigning any to these, and it doesn't like that, so it wants us to do something here. So what we'll do here is we're going to define A is going to be a number, and B is going to be a number. And so now if we tried to pass anything other than a number, it's going to yell at us. So it says the string is not assignable to parameter of type number, so it must be a number. And now if we hover over this, we can see that we have A as a number, B as a number, and then notice at the end of the function there, it has another colon number. So that means it's going to return a number. So it'd be the same as typing colon number here. So we're explicitly saying here that this function is going to return a number. But again, we don't have to type this because TypeScript is inferring that it's going to return a number because of our return statement here and the fact that it's passing in numbers. But what if we want to make sure that a function functions as intended? We should declare that function first before we write it. So this time I'm going to rewrite this function as an arrow function. I'm going to say let calc sum, and then I'm just going to define the types. So we'll say A number and B number, and then arrow, and we're going to return a number. Okay, so we're just defining this. This is a function. It's going to accept two parameters that are numbers, and it's going to return a number. So since we've defined this, now when we actually write the function, it's going to ensure that we write it correctly. So we'll say calc sum equals, and we'll say first, that's going to be a number, second, a number, and we're going to return first plus second. Okay, so that works just fine. Now, these don't have to match. A, B, you can put whatever you want here. And then you can name them here when you're actually defining the function. So now, because I have this defined up here, if for some reason I forgot to return, then it's going to yell at us and it's going to say that it's returning a type of void, and it should return type of number. So we'll get to void in a minute, but we need to return this number for it to function properly. Now, sometimes in functions, you have optional parameters. So we could also say that we have a third parameter, and that is going to be a number. Now, if we go down here and we actually call calc sum, we pass it 2 and 2, it's going to yell at us because it's expecting a third number. Third is not provided. So if this parameter is optional, we can just add a question mark before the colon, and now we can pass 2 or 3 values. And always be sure to have your optional parameters at the end of your function. You can't have an optional first because the first value needs to be there. Really quick, like and subscribe. It helps me out. Okay, so earlier we saw that void is a type. So let's look at this. We'll say const, say hi, equals an arrow function. And we're just going to console log hi. Okay, so this function returns void. So void is nothing. It's not undefined. It's not null. It's just a complete lack of anything. All right, moving on, we'll look at interfaces. So interfaces enforce a certain structure of an object. So we're going to say interface. Now this is going to look very new. So we're going to say person interface. And we're going to say name is going to be a string and age is going to be a number. Okay, so this defines a person object and what it should look like. So very similar to earlier, we had a person and the person had a name and an age. This just defines what that person object needs to have within it before we actually assign any values to it. Okay, so in order to use this, we can say let Mike, and Mike, let's just say equals an object for now. We're going to say name Mike, and then age is going to be 34. Okay, so if we hover over this, we can see that Mike is an object, just a normal object, and this looks just fine, but we want to make sure that Mike adheres to the person interface, that it has all of the types from the person interface. So we can do that explicitly here after Mike. We say Mike is actually not an object, technically, it is a person interface. So now if we hover over this, we say Mike person interface, and now if we changed this here to a number, that would yell at us because it's expecting a number. If we took this back off, we can see that it's just fine because we're declaring that here. Mike has a name that is a string and age that is a string because we're defining it here. But instead of defining it here, we want to define it here so that we do it correctly. So now we know that this needs to be a number and not a string. And we can use interfaces on classes as well. So let's look at a class. We'll get rid of this. We'll say class of person, and we're going to say implements person interface. So we need to have a name that is a string and an age that is a number. And in classes, we have to have a constructor. So we'll say name is a string and age is a number. Then we'll say this dot name equals in and this dot age equals a. All right, so this all functions properly as a class should. So we're defining name and age, and then we're taking our constructor. Again, this in and this a, this you could put whatever you want here as long as you assign them to the proper values down here. So this dot name is referring to the person name. We're assigning it to the name string. And then this dot age equals the age string, right? And all of this is working together to make sure that it functions properly. If we tried to add something else, let's say email, and that is a string, that's not going to work because this needs to adhere to the person interface, which only has a name and an age. So we could also add a method onto this class. We're going to say greet. And then in here, we're going to return. We'll say, hi, my name is, and then we'll add this dot name, and I am, and then this dot age. So now in order to use this, we could say let John equal a new person. We're going to say that his name is John and his age is 35. And then we can console log John.greet. We can see now that we don't have any red squigglies anywhere, so it's very likely that our code is going to work just fine when we run it. Let's go ahead and run this actually. We're going to save that. Now we need to recompile it, so we're going to go back and into our terminal, tsc, recompile, and then let's go back to our website. All right, so we can see here it says, hi, my name is John and I am 35. And this error has nothing to do with TypeScript. So another cool thing about classes is the ability to add access modifiers. So we can say that certain values or methods are private, public, protected, or read-only. So for instance, right now on John, we could say, what is John's age, name, or we can call the greet method. If we go up here, we could actually say that name is private. And now if we go down here to John, and we check, we can now no longer access name outside of the class. Now within this method greet, it can still access the name, but that's because it's still inside the class. So that's pretty cool. We can also rewrite this to be a bit cleaner. So let's get rid of this. We're going to say constructor. We're actually going to get rid of the assignment as well. So we're going to say constructor. Now we have to use the access modifiers for this to work. So we're going to say public name is a string, and we're going to say public age is a number. And that's all that we actually have to do. It's going to automatically assign these values because we declared these just like this with the access modifiers, the name, and the type. So this looks a lot cleaner. And again, now we can call age, name, or greet. So next, let's look at DOM and typecasting. So we're going to implement what we've written so far into our HTML so that we can interact with the DOM. So in the body, we're just going to write some simple HTML here. We're going to add a form. It's not going to have an action. Inside the form, we're going to have an input, and it's going to have a name of name and then ID of name. We'll have an input that is a number, and that's going to say age and age as the ID. And then another input that is going to be a submit, and we'll say hi. Now after the form, we're going to have a div with the class of greeting. Whoops, greeting, just like that. All right, that's all of the HTML. We're not going to add any CSS and style this. This is just an example. So now we need to get our inputs. So we're going to say const input name is going to equal document.query selector, and we're going to get the ID of name. Now, if we hover over this, TypeScript is going to tell us that this is a type of element or null. So it knows that it is some type of document element, but it doesn't actually know if the element exists. It doesn't have access to the HTML file. So that's going to come into play a little bit later. Just remember that it could be null, but it is of type elements. So if we go down here and we say input name, and we want to get the value of the input. So value, and we can see that it's not popping up as a selector here. So IntelliSense isn't really working that well right now because it doesn't actually know that it's an input. So if we go up here and we change this from the ID of name to an input, and now we hover over it, we can see that it is of type HTML input element. So that's what we want it to be. So now let's change this back to name as, we're going to say HTML input element. So now if we hover over this, we can see HTML input element. That's the proper type. And now if we try to get the value, we can see IntelliSense is helping us out, and we can actually select the value. And we can see how when we set this up properly and we declare things properly, IntelliSense is going to help us out, and it's just going to make our development lives so much easier. So let's get the input age now. So we'll say input age is going to equal document.query selector, and that was age. And this is also going to be an HTML input element. All right, we also need to get the form. So we'll say input form because we need to know when the form is being submitted. So we'll say document.query selector, and then that was a form. And now because this is just a form tag, TypeScript knows that this is an HTML form element. So we don't have to typecast it. Again, I think I forgot to mention, this is called typecasting. And then the last thing that we need to get is the greeting div. So we'll say greeting going to equal document.query selector, and then that was a class of greeting. Okay, so now this is going to see this as an element, but we do need it to know that it's a div element. We're going to leave it like this for now, and we're going to come back to it and fix it later because I want you to see why we need to typecast this as a div element. So now, instead of getting or setting the person element manually, we're going to get that from the form. So we need to add an event listener on the form. So we're going to say input form add event listener, and we're going to listen for the submit event, and then we're going to have an arrow function. All right, so now it has this like question mark dot event listener because it's not quite sure if this form is actually there. So it's kind of doing a little check to see if the form is there. If we got rid of that, then we're going to get this little squiggly saying that it's possibly null. We don't actually know if it's there. So in order to fix that, we could, again, add that question mark here, or we could go up here and on this form at the end, we can add an exclamation mark. So that's going to tell TypeScript that this form is actually there. You don't have to worry about it. So now on submit, we want to get the input values and then use the class to return our greeting string. And then we're going to display that string on the page. So back in our event listener, we do need to get our event because we need to say e.prevent default because we don't want, when we submit the form, the default behavior is for the page to refresh, and we want to prevent that page refresh. So now we're going to get a const of person and say equal to a new person, and we're going to add the input name dot value and the input age dot value. Now you would think that input age dot value would be a number, right? Because if we go back to HTML, the input type is number. If we go back here and we hover over this, we're going to see that it is actually a string. And that is true. The input is of the type number, but it actually returns a string with a number in it. So for this instance, instead of value, we need value as number, and that will clear up all of the issues. All right, so now we need to add this greeting. So we're going to call this greeting method, and we're going to add that into our greeting HTML element. So we're going to say greeting dot inner text, and notice here that it doesn't find inner text. And that is because, remember, we said we need it to know that this is a div element. So if we change this out to a div and then hover over this, we can see that it is HTML div element is the proper type. All right, so let's undo that. We're going to say as HTML div element. And now when we go down here, we can see inner text is an option now. So now inner text is going to equal person.greet. All right, and then the last thing that we're going to do is we're going to say input form dot reset. Okay, so we just want to reset and clear out the input values whenever we submit. So that should be it. We don't have any red squigglies. And now one last thing that I want to show you is, again, we need to run TSC again to recompile this. But let's say that you're working on TypeScript a lot and you don't want to keep hitting TSC every single time you save and you want to test something. So we can actually say TSC-W, and that's going to watch all of our TypeScript files and automatically recompile them every time we hit save. All right, so we'll hit watch. And now if we go up here and we hit save again, you can see that it has recompiled again. So let's go back to our website. Okay, so we have two inputs. We can have our name and we have our age. So we'll say name and age, and then we can click say hi, and we get, hi, my name is Jesse, and I am 35. It clears the form. We can fill it in again. We can say Mary is 25, and now we get that. So it's working perfectly. All right, next we're going to look at generic. So sometimes there may be instances when you don't know exactly what type something might be. And so we're going to look at a generic in a function first. So we'll say function do something, and that's going to have an argument here. And then we're just going to, do something and then return our argument. So this is a normal function that would work just fine. Now it wants us to tell it what kind of argument this is. So let's say we call do something and we're going to pass it a string, right? Maybe sometimes we might pass it a number. We're not quite sure what we're going to pass it. So we can't really define what it is here. So to do that, we're going to say t. And then we're going to say the argument is t. So this can be anything. You could say x. You can put whatever you want here. Generally, you're going to see an uppercase T here. But basically, this is a placeholder. So whatever we pass into this placeholder is going to get pushed on to the type here. And we can even say that we're going to return T, right? We can do all of this. And if we hover over this, it's going to show us exactly that. And now when we pass a number in here, it's working just fine. If we pass a string, it's going to work just fine as well, because it's going to say that it is a string. So if we hover over this, we can see that a string is being passed into all of those types. If we change this back to a number, now a number is being passed. Now we could specifically say that here as well. We could say string needs to be passed, but we're passing a number, so that's going to fail. So if we change this into a string, now it passes. We can also use this with interfaces. So let's go down here. We could say interface book, and the book needs to have an ID, which is going to be a number, and it needs to have a name, which is going to be a string, and it needs to have some data, which we're not quite sure what the data is going to be. It could be lots of different things. So in order to pass this option up here on book, again, we're going to say T, and then we can pass this T here as the type. So then when we go down, we can say const a book is going to be a book, and it's going to equal an ID of 1. Name is going to be title 1, and then data is going to be, let's say it's a string this time. So more data here. So we need to tell it that this is a string. So we'll say right here, we're going to say string, and that's just fine. So it takes this string and it passes it here, and it puts the string type into this data. So it knows that we're going to have a string here. If we change this to a number, that's obviously not going to work. It needs to be a string. And let's say we have another one. Let's say const bbook is going to be book. And we're going to pass something here in just a minute. Equals, we'll say ID is 2. Name is going to be title 2. And then data. This time the data needs to be an array of strings. So we're going to say array. Maybe this is a review 1, and then review 2. Right? So in here, we're going to tell it what that type is by saying string array, and that will work just fine. So both of these, this one is a book with a string, a single string, and that's working. But this one has an array of strings, and it's working as well. All right, next up, we're going to look at enums. Enums are a way to assign a descriptive word to a numeric value. So a lot of times in a database, you might see something has a type of 2 or a type of 3, and you're not sure what that type is. You have to go find the type table and figure out what is this type. So in order to demonstrate that, let's write something out here. So let's say we have a const of my car, and that is going to equal an object. We'll say the year is 2021, and the make is going to be 3. So this is something you'll commonly find in a database. The make is 3. Well, what does that 3 stand for? So to make things easier, we can declare an enum. We're going to go up here and we're going to say enum. And we'll say manufacturer make. And that is going to equal an object. And we're going to say, we're going to put a list of manufacturers in here. So we'll say Tesla, Audi, Mercedes, Volvo, and BMW. Oops, didn't mean to put the equal sign there. No equal sign. Enum, manufacturer, make, and then the object. So within this, think of these as indexes. So index 0 is going to be Tesla, 1 Audi, 2 Mercedes, 3 Volvo, and 4 BMW. So now, instead of having to remember, okay, 3 is supposed to be Volvo, right? I can just say manufacturer make dot Volvo. And this is going to actually put in here the number 3. And we can see that. Let's do a console log. So we're going to say my car dot make, and we're going to get that in our console. So let's save that. And remember, we still have the watcher running. So all I have to do is go back to my site. Let's open up the console again, and we can see the number 3. So that is the basics of TypeScript. You can use it just about anywhere that JavaScript is used, such as in Angular, React, Vue, Node.js. So in future videos, we'll look at incorporating TypeScript with these other technologies as well. So I hope this helped. That's going to be it for this video. Like this video to help me out, and subscribe if you haven't already for more videos like this.